Section 2.3, Part A here. We're looking at dividing polynomials by long division and synthetic division in this section. But we're going to begin with just dividing monomials. When I divide monomials, I use this property. A plus C divided by B is the same thing as A divided by B plus C divided by B. That is, that if I have a binomial divided by a monomial, I distribute the division so that both A and C get divided by B. For example, in part 1, if I have 5x minus 15 over 25, this is the same as 5x divided by 25 minus 15 divided by 25. Then I can reduce these separately. So 5x divided by 25 can be written as x, because what I'm doing here is dividing by 5, right? If I'm dividing by 5, that's 1x, which is just x, over 5, minus 15 divided by 25 can both be divided by 5, which would give me 3 and 5, so minus 3/5. Okay. Now, note, some people like to write this as, instead of x over 5, write the number of x's, there'd be 1, so you could write this as 1/5 x minus 3/5. That's the same thing. You can slide the x off the side if you put the coefficient 1 on top. And that's because 1/5 times x over 1, if you put x over 1, 1 times 1 puts the x back in the numerator. It's a different way of writing it. So either of those is fine. Okay. Part B, we're going to work this one similarly. You have 18x to the 5th divided by negative 6x cubed plus 5x to the 4th divided by negative 6x cubed minus 6x cubed divided by negative 6x cubed. Once again, we are distributing the division to make sure every piece in the numerator gets divided by the denominator, since the denominator is monomial, one term. This one finishes by reducing. 6 goes into 18 3 times, into 6 once. And if you subtract the powers, you'll be able to reduce the x's. So first the number. Don't forget about your negative. So that's actually going to move to the top and become negative 3. And then for the powers, you subtract. And so you've got x to the 5th over x to the 3rd. 5 minus 3 gives me x squared. In the numerator, there's actually nothing left in the denominator besides a 1, so I don't need to write the denominator. Okay, in the next one, don't forget that negative again. That negative with that positive are going to combine to a subtraction. Then you can't reduce the 5/6. And the x's, you have 4 on the top, 3 in the bottom. It leaves you with 1 in the numerator. You could slide that 1 in the numerator off to the side, and it would be the same thing, just like we did over here with sliding the x off to the side. Last, 2 negatives. So 2 negatives are going to become positive. 6 goes into 6 one time. X to the 3rd over x to the 3rd reduces completely, so you're just left with 1. One more. Once again, monomial denominator, distribute that denominator. So we've got 6 w to the 5th p over 6 w squared p plus 12 w to the 4th p squared over 6w squared p, last, plus 2 w to the 3rd p to the 3rd over 6w squared p. Reduce each part. 6 goes into 6 once, so that gives me 1 as the number. The w to the 5th over w squared gives me w to the 3rd in the numerator. The p's reduce evenly. There's nothing left in the denominator, so that's just w cubed. Okay. You can divide both 6 and 12 by 6, leaves you with 2 on the top, 1 on the bottom. W to the 4th over w squared, subtract those, leaves you w to the 2nd in the numerator. P to the 2nd over p to the 1 gives you p in the numerator. Nothing left in the denominator, so once again, I don't have a fraction for that part. Last one, you can divide both 2 and 6 by 2, leaves you with 1 in the numerator, 3 in the denominator. And w to the 3rd on the top minus w 2nd on the bottom leaves you with just a w in the numerator. P's, p to the 3rd over p. So 3 minus 1 is 2, so p squared also in the numerator. That's done. Okay, so in conclusion, when we divide by a monomial, it's similar to using the distributive property. And just a couple examples of the distributive property. If I distribute this 3x times 2x would be 6x squared. 3x times 5 will be plus 15x. And if I distribute the division, 6 divided by 2 is going to be 3. X squared divided by x is going to be x, so 3x. Minus 10 divided by 2 is 5. X divided by x, the x's are gone. So you can do the distributive property. I don't necessarily have to write denominator under each step in order to reduce them if I can visually reduce them. Okay, and that's the end of part A.